Linear function. Linear function is the function of the form f of x equal ax plus b. The graph of a linear function is a line with the slope a and the y-intercept b. Let f be a linear function. Make the table of values and sketch the graph of f. So I'll pick this value for the x. So I first order pair -2, -8. Zero, -2, 2, 4, and I will connect the line. I'm going to extend this a little bit. So this is our line. Now the next thing, identify the slope of the graph and compare it to the average rate of change. Well, the slope f of x equal ax plus b. So the slope a is equal to 3. So let's calculate the average rate of change. Let's calculate the average rate of change between 2 and -2. That is f of 2 minus f of -2 divided by 2 minus -2. That is 4 minus -8 divided by 4. This is 3. So note that the slope of the graph and the rate of change is the same for linear function. So make a note. Okay. Slope and rate of change. For the linear function f of x equal ax plus b, the slope of the graph and the rate of change are both equal the coefficient of x, that's a. Proof, let's calculate the average rate of change of f of x on the arbitrary interval from x equal t and x equal t plus 8. So the function f of x equal ax plus b. And we claim that the slope a is equal to the average rate of change. Okay, so let's calculate average rate of change between t and t plus 8. It's given by the formula f of t plus 8 minus f of t, divide t plus h minus t. So f of t plus h, we will replace x by t plus h in the equation. Expand and combine like term. So as you can see, the average rate of change in an arbitrary interval t to t plus h is equal to a, and that is the slope of the linear equation. Okay. Making and using the linear model. A large koi pond is filled from a garden hose at the rate of 10 gallons per minute. Initially, the pond contained 300 gallons of water. Find a linear function v that models the volume of the water in the pond at any given time t. So let's try this. So if the rate of change of the water in the pond, this is the rate of change, the average rate of change. Okay, so every minute, the water in the pond increased by 10 gallons. So it starts out with 300 gallons of water. Then the function that would represent the volume of the water in the pond at any given time t, v of t, is equal to 10 gallon increase every minute plus the initial amount of water that is in the pond. If the pond has the capacity of 1300 gallons, how long does it take to completely fill the pond? This means here it's given you v equal to 1300 gallons and asking to solve for t. So we are given 1300 is equal to 10t plus 300. So 1000 equal 10t. So t equal 100. So it takes 100 minutes to fill the pond. The manager of a furniture factory found out it costs $1,200 to produce 100 chairs in one day, and $4,800 to produce 300 chairs in one day. Okay. Assuming that the relationship between the cost and the number of chairs produced is linear, find a function c that models the cost of producing x chairs in one day. So here we are given the information to calculate the rate of change. The cost increased by producing one chair per day, and we don't know the initial cost. So what we need, so we want to look for a function c of x, where x is the amount of chair, is equal to ax plus b. So we need to find the average rate of change, a, and we need to find the initial cost, b. And we will calculate this based on the information that we are given. So in part A, A1, we want to find the average rate of change. Well, we know that the change is from 100 chair to 300 chair. So then A is equal to the cost of 300 chair, that is 4,800, minus 2,200, divided by the difference between 300 chair and 200. So it costs $26 each chair. $26 to produce one chair. Step 2, we want to find the initial cost. Well, we know A, f of x, is equal to 26x plus b. Now I will use the information that is given to us, one of the order pair. If it costs $2,200 to produce 100 chair, I can plug the information into my equation that I just come up with in order to figure out b. So I know that C of x, the cost is $2,200 to produce 100 chair. I can solve this equation for b. Okay. So the initial cost is negative 400. It makes sense, right? The initial cost, if you don't produce any chair at all, then you lose money. You don't sell chair, so you lose money here. So then the cost, the function cost, the cost to produce each chair is equal to so this is part A. Okay. In part B, identify the slope of the linear function. What does the slope represent? Well, the slope is 26. So this slope represents the cost of producing each chair. Okay. Take a look at the next problem. West Albuquerque, New Mexico Route 40 eastbound is straight and make a steep descent toward the city. The highway has 6% grade, which means that the slope is negative 6 over 100. Driving on this road, you notice the elevation sign that you have descent 1,000 feet. What is the change in your horizontal distance in mile? So let's draw a picture. So let's say you travel down the hill this way and start in here. Okay, and it's telling you that the slope is negative 6 over 100 because it's decreasing. Now, if you have descending 1,000 feet, which means from here where you started to say here where you noted where you are, this distance here is 1,000 feet. And you are asking for what the change in your horizontal distance. What is x equal to? So since the slope is the change in y divided by the change in x, if you start by this coordinate here 0, this distance here is x. Then 1,000 divided by x have to equal the slope. That is negative 6 over 100. You can solve for x in this case. So this is about 16,667 feet. Okay. Negative. So because we're talking about the horizontal distance and the distance need to be positive, this means the change in your horizontal distance in feet is 16,667 feet. But the question asking for it in mile. So we need to change it into mile. And that is 31.56 miles.